Today we'll be discussing the concepts of limit, right? Suppose we have given the function fx and this is the graph of fx, right? Now suppose if we want to find the limit of x tends to -4 for the fx, right? Now what can we see? What will the value of fx at x tends to -4, right? So at fx tends to -4, the value of fx is 0, right? In the same way, like if I want to find the limit of x tends to 0 of fx, so what is the value of fx when x is equal to 0, right? Now we see at x is equal to 0, the value of fx is 2, right? Now in the same way, if I try to find what will be the limit of fx when fx tends to 3, right? So now we can see from the graph at x is equal to 3, the value of fx is -1, right? So these are the concepts of limit. Now we'll further discuss the more concepts. Now the next concepts in limits is one is the right hand limit and the other one is the left hand limit, right? Right hand limit and left hand limit. So what is the right hand limit? Suppose if I want to say fx limit x tends to a plus, so this is the right hand limit, right? And suppose if I want to discuss the left hand limit fx for x tends to a minus, right? Suppose this is my fx and this is a point x is equal to a, right? So if I go right to the a small distance, this is my right hand limit, right? And if I go a left to the a, so this is a left hand limit, right? So the distance of a plus is, we can consider a plus as a plus h, right? And this h will be a very small value, right? That will be going to that value we can consider as a negligible, right? So the value of h will be very less. These are known as the right hand limit and the left hand limits. Now we'll discuss the more concept about limit, how to solve the problems of limit, right? Now if I give you example, suppose you have to find the limit of fx. Suppose a function fx is given as x square plus 2x plus 1, right? This is our fx and we want to find limit fx and x tends to 1, right? So what I have to do, I just have to put the value of 1 in the fx, right? So now if I put the value 1 in the fx, so this will be 1 square plus 2 into 1 plus 1, right? So this will be 1 plus 2 plus 1, right? So that is 4. So what can I say? That limit of fx when x going to 1, so my limit of fx is equal to 4, right? So this is an example of limit, right? Now we'll solve more problem. Like suppose if I want to say fx is equal to 2x plus 1 and I want to find limit fx where x tends to c, so what can I say? I'll just have to put the value of c at the place of x, right? So this will be 2 into c plus 1, so the answer will be 2c plus 1, right? Okay, now we'll discuss the more concepts of the limit. Now the next method to find the limit is the factoring method, right? Now here we do the factor of the function and try to find the limit. Now suppose if I say my function fx is equal to x square minus 9 over x minus 3, right? And I want to find limit of fx when fx tends to 3, right? Now if I do the direct substitution like we did before, if I put the value of x is equal to 3 in this function, so this will be 3 square minus 9 minus 3 by 3, right? So this becomes 0 by 0, right? So 0 by 0 is not defined, right? We can't predict the value of limit. So what we do here, like I'll put my fx is equal to x square minus 9 over x minus 3. So we know that a square minus b square is equal to a plus b into a minus b, right? So I can substitute this as a x plus 3 and x minus 3, right? Over x minus 3. So finally I get my fx as x plus 3, and if I now put limit x tends to 3, so I got the value of this function as 3 plus 3 and that is equal to 6, right? So this method is known as the factoring method, right? Now if we try to solve two more problem over this concept, so that can be fx is equal to x square minus 4 over x minus 2, and I want to find limit x tends to 2 fx, right? So now in the same way, we'll do the factor first, then we'll try to put the value, because if we directly substitute the value, we are getting the function is 0 by 0, right? So that is not the limit. So if I try to factor this will be again x plus 2 and x minus 2, right? Divided by x minus 2, this will cancel out, and if I put limit x tends to 2, so this will be 2 plus 2, and I got my answer for the limit is equal to 4, right? I hope you are able to understand this part. Now we'll solve the more problem. The second concept we have to solve this problem is the conjugate method. Right? In the conjugate method, what we do, like suppose we have to find the limit, our fx is equal to root of x plus 11 minus 4 over x minus 5, right? And we want to find limit at x tends to 5, right? Now if you put the value of 5 here, this again reduced to the form of 0 by 0, right? We are not getting a definite answer for this. Okay, right? So now in this case, what we'll do, we'll try to reduce the numerator with its conjugate. We'll multiply the numerator with its conjugate, and we multiply the same with the denominator. So what will the conjugate of root x plus 11 minus 4? Root x plus 11 minus 4 will be, the conjugate of this will be root x plus 11 plus of 4, right? So if I multiply this factor in the numerator and the denominator, so what fx I will be getting, so that will be equal to root x plus 11 minus 4 over x minus 5 into root x plus 11 plus 4 by root x plus 11 plus 4, right? The same. So this will be equal to 1, right? If I cancel both of them, so it doesn't change our function, right? So now this again reduced in the form of a minus b and a plus b, right? So that will be equal to a square minus b square. So this is my a, this is my b. So how can I write this as a x plus 11? If I square, then under root will be cancel, right? X plus 11 and 4 first will be minus. So that will minus 16 over x minus 5 into this function root x plus 11 plus 4, right? Now this function reduced to, my fx now reduced to x minus 5 over x minus 5 into root x plus 11 minus 4, right? This will be cancelled out. So my final fx is 1 over root x plus 11 minus 4. Now for x tends to 5, what if I simplify this, this will be, if I put value of 5, this will be 5 plus 11 minus, sorry, this will be plus, right? We are multiplying with the plus, so plus 4, so this will be 1 over 4 plus 4, so that will be 1 by 8 answer, right? So this will be my limit of fx when x tends to. Now we'll discuss this L Hopital rule, right? This rule we can use when suppose we have a function fx over gx and x tends to c, this is our limit, and this fx over gx is reduced to any kind of form like non-deterministic form, right? We can't determine like 0 by 0, we can't determine like plus minus infinity over infinity or infinity minus infinity or 0 to the power 0, right? Infinity to the power 0. When we will encounter such kind of fx over gx like that are 0 by 0, infinite by infinite, infinite by minus infinite, we can determine the exact values, right? So in that case we'll be applying this L Hopital rule, right? Now we'll solve some problem like suppose our fx that is equal to e to the power x minus 1 over x and x tends to 0, right? This is the limit, and I want to find this value of this fx for x tends to 0. Now you can see if I put x is equal to 0, so e to the power 0 is equal to 1, right? So this will be 1 minus 1 over 0, right? So this is 0 by 0, so I can't determine the limit. So what I'll do in this case, I'll apply the L Hopital rule. So what does the L Hopital rule says? That I will differentiate this fx, if this form is 0 by 0, then I will differentiate the first function and I differentiate the second function, and then I'll apply the limit for x tends to 0, right? So what will be my f dash x of e to the power x minus 1? So that will be e to the power x differentiation is e to the power x, right? And 1, it will be 0, the differentiation of 1. And what is g dash x will be? The differentiation of x, that is equal to 1, right? So my function now reduced to e to the power x, right? And now if I applied the limit for x tends to 0, so e to the power 0 is equal to 1, right? So my answer will for this problem will be equal to 1, right? Okay, we'll do one or two more problem to understand exactly how we can apply this rule to the different situations, right? Suppose next I have x square over 2 to the power x. This is my fx, right? And I want to find the limit when x tends to infinity, right? So now if I put infinity direct by the direct substitution, so this will be infinity square by 2 to the power infinity, so that is infinity over infinity, right? Now I don't know how to solve the infinity by infinity, so now this is infinity by infinity, so I can apply the L Hopital rule, right? So suppose this was my fx. So now what, I will differentiate this first function and I'll differentiate the second function separately, right? So what will be the differentiation of x square? That will be 2x, right? What will be the d by dx of 2 to the power x, right? So 2 to the power x is 2 to the power x into ln 2, right? You can also write the general formula. The differentiation of a to the power x is a to the power x ln a, right? I'll substitute this. This is 2 to the power x into ln 2, right? And now again x limit tends to infinity, correct? Right, now again this is a infinity by infinity function, right? If I put x is equal to infinity, so I'll differentiate this again, right? So if I differentiate this function again, so that will be 2, and I differentiate this function again, so that will be, I can take ln 2 outside, this will be 2 to the power x into ln 2, right? So now my function reduced to 2 over ln 2 square into 2 to the power x, right? And now this is my fx, right? And now again I have to put limit x is equal to infinity, so I know this is, now this can't be reduced again, right? This is 2 over infinity, right? So anything over infinity, that is equal to 0, right? So the solution to this problem will be 0, right? I hope you were able to understand this also. We'll do one or more problems over the same concept. Now suppose I have a question that sine x over x when x tends to 0, right? This you can prove as a theorem also, or I can give you the explanation of also that sine x over x when x tends to 0, this is always equal to 1, right? Because now see, if you directly put the 0 over 0, this turns out to be sine 0 over 0, right? So that is equal to 0 by 0 form. So what we'll do, we'll differentiate this first function and then we'll differentiate the second function, right? So the differentiation of sine x is cos x over differentiation of x will be 1. Now if I put x is equal to 0, so we know cos of 0 is equal to 1, right? So the solution to the problem will be 1. Suppose I have a function that is e to the power x over x cube, right? X tends to, and now here x tends to infinity, right? So now this again, this form reduced to infinity over infinity, right? Because e to the power infinity is infinity. This is how the graph of e to the power infinity looks. That is always positive and goes up to the infinity, right? And the graph of x cube will be this, right? At the infinity is also approaches to infinity. So now what I'll do, I'll differentiate the first function and the second function. I'll apply the L Hopital rule, right? So e to the power x integral will be e to the power x, sorry, differential will be e to the power x, and x cube will be 3x square. Now again I put infinity, so this goes to infinity over infinity, right? So I'll have to do the differentiation again. So this will be again e to the power x over 6x, right? Now if I put x tends to infinity, so this again becomes infinity over infinity, right? So this is also non-deterministic. So what I'll do, I'll differentiate this again, so that will be e to the power x over 6 and x tends to infinity. So now finally if I put e to the power infinity, so this will be infinity, right? So answer to this problem is infinity. Okay, I hope you were able to understand this problems on limit. If you have any doubts, you can write in the comment section. I will look over it and I'll try to give you the solution. And you can also let me know which topics you want me to cover. Okay, thank you. I hope this helps.